Hello everyone. Welcome to Continuous Delivery for Legacy Code. I'm Richard. I'm kind of down in the bottom corner there. I work for this nice company called My One Wolf. If you cannot pronounce it, it's German. And we're not a law firm. We actually do consulting. For example, we develop stuff, or me specifically, I develop stuff. We do software archeology, meaning, you have kind of this code and you don't really know how it got there, and you kind of figure out why and how and what you can change about it. And then, of course, we also do audits, but it's sort of to scale. So if audit is very small, that's because audit is also very small for me. Anyway, if you want to comment, please do. I don't think I'll be able to do this, do the comments while I talk. But if you want, please go to slido.com with the hashtag buildstuff2019. Okay. So, anyway, who here works in legacy code? Okay. Who considers legacy code to be something he wrote yesterday? Okay. So this will be interesting. Okay, thanks. So this is actually a true story, mixed with some other true stories. And basically it's the worst code base I ever encountered. It was so horrible. And yeah, but let's start in the beginning. Let's start with some definition. What is legacy code? So, and this is kind of scary for me because the two people who gave the most perfect definitions are actually here at the conference. I hope not in the audience, actually. Oh well. So anyway, so this is Dalan. Butchered his name, anyway. And he said legacy code is code that's too scary to update and too profitable to delete. And that's kind of hits the point, right? Because if it wasn't profitable, we wouldn't have the legacy code, right? On the other hand, there's this other part called too scary. Why is it too scary? Well, legacy code is code without tests. If we don't have tests, we're afraid to change it. It's very simple. Now, the talk is continuous delivery for legacy code. So what is continuous delivery? Well, this is the definition from the book. And it says, if somebody thinks of a good idea, how do we make it feasible to deliver to users as quickly as possible? This is right in the beginning. It's the first sentence. And that's kind of the heart of the topic, right? I mean, it's too scary to change, but you kind of want to push new ideas to production as fast as possible. So let's start with the story. It was a beautiful spring. I felt so good. And customer called, right? Customer's always king. It was like, hey, so there's this software, customer off-the-shelf software. It's called Apocalypto. Yeah. And he asked me, well, can you please audit it? I was like, yeah, sure, let's audit it. So this is what we got delivered. It was 4 million lines of code. It was very many different software pieces. So you had an Excel spreadsheet, you had a website, you had some jobs which ran periodically, sometimes by being scheduled, sometimes by automatic trigger. You had this fat client, which you can install on different computers, a web service, which you can also query, and of course you had a database. And as you can see on the right-hand side, many different languages. 15 years old. Who here knows classic ASP? Oh, well, there you go. So classic ASP is this magical thing where you basically have a singular file, and whatever you want to do, this file in the end gets rendered like PHP, right? And in there, every time you want to do some business logic, you want to call a database procedure, you basically have to code it in there. You cannot do some abstraction, or where you can hack it together, but basically you write your SQL statements directly next to your HTML. So, which is exactly what they did. So you had the website, and they start with classic ASP and VBScript, and then they're later on, 15 years old, they replace parts of it with C# and ASP.NET. and you had this Excel, and Excel, actually, maybe you don't know. So Excel, you can extend. The ribbon bar in the top, you can basically put new ribbons in there completely dynamically. They use this Excel sheet because, well, they had tabular data. They wanted to display it. And what do? Well, it's an Excel sheet. So let's have VBA code, which calls our backend. I mean, but, not the website, like SQL statements directly. So, of course, they put the logic for the SQL statement stored procedures in the database. And then the Excel sheet can, in the end, display the stuff you want to display. And, of course, you have a web service for some API queries from the outside. Jobs, fed client, and, well, whole bunch of missing code, including, as it turns out, the database. Yay! So we were missing 1 million lines of code, which was about 2,600 stored procedures. And if you count that down, you can see that the stored procedures had lots of lines of code. And yeah, so that was fun to find out. And of course, you didn't have a single database, you had the replicated database. So if you've ever handled SQL Server replication, you know it's not fun, and please don't ever use it. Unless you know what you're doing, which wasn't me, and I don't know how to use it correctly. Of course, this wasn't just SQL Server replication. You had it also inside the database using triggers, like a lot of them. You change one database table and suddenly these 60 other tables also change. So yeah, we said nope. It doesn't even compile. Right? 4 million lines of code, 1 million missing, and the stuff we got doesn't even compile. Business logic is pretty much everywhere. It's on the database, it's in the presentation layer, it's anywhere you want, and database calls are also everywhere. The deployment. So, because VBScript is a scripting language, you don't have to compile stuff. So if you want to, create a new feature, you can log into production. Yeah, so that was the deployment. Copy pasting code into production directly, which is fun. You can do it, but shouldn't you have a test environment in between? Nope. Every form of duplication I can imagine I found in there, which had the amazing benefit that we had zero coupling. Yeah, depending how you define coupling, obviously you had coupling because you change this line and then you need to change that line, and that line. But the metrics don't give it to you. You had zero tests, of course, and it was 15 years old. I mean, 15 years old. There's probably good software out there that's 15 years old, but this one wasn't. Anyway, so that's what we gave the customer. We told him, yeah. Do you really want to buy that? He's like, sure, let's buy that. And he changed the name to Phoenix. Oh, cool. Okay. Anyway, and then he was like, yeah, sure. I mean, that's fine. Can you please fix it? Oh boy. Yeah, so I don't know if you thought of this, but I have. We could just, why not rebuild it? I mean, honestly, why not? And I have an opinion on this, and I don't think it's a good idea to always rebuild, even in this case. And we'll come to why this would have been a bad idea, because we didn't. Anyway, so this is the true cost of rewrites. So imagine you have on the y-axis the features you have implemented, and you have the releases over time on the y-axis. So when you start, you estimate, and you're like, 15 years, these and these are the features, and so on. So that's the plan scope, right? And then we can increase further on. But at one point, you actually reach that point, and then you look like, well, the old app was, they didn't stop development, they continued developing it. So you have some catching up to do. And like, okay, fine. Now we've caught up. Good. Okay. So now you're already gone above your planning, right? Because you had to catch up. And then you look at the code and you're like, well, I guess we have a problem because now we're subpar. We have exactly the same features, possibly, but we have all this undiscovered scope we didn't think of. So now you have to implement all the scope you didn't think of when you did the planning. And you have to, implement the missing features you forgot. Or, well, forgot is a bad term. You didn't know about them, right? So now you have parity. Great. But why should anyone use the new app? It's got exactly the same features as the old app. I mean, honestly, why? So you have to do some enhancement. You have to actually do something which is a selling point for the new version. And that's when you get adoption. I mean, obviously, we're not talking about 4 times as long, but you can see why your planning is pretty much always screwed up in some form or another. And yeah, sorry, down the bottom, that wasn't my idea. It's the original article is by Doug Bradbury. Anyway, so early summer. Okay, we're gonna help the customer fix this somehow. So in my mind, the first question is, the original developers, how did they get here? I mean, they didn't start out wanting to build problematic software. And I think, well, it's all models are wrong, but this is the model I came up with. And it says you have the product in the center, and it's basically influenced by 3 factors: by the spirit of the team, by the process, and by the actual ideas. And, well, garbage in, garbage out. If one of them is empty, you get this. I didn't change the ideas down on the bottom because I think the idea itself was solid. Otherwise, too profitable to delete. Otherwise, we would have already deleted this legacy code. So for this talk, let's not talk about the ideas. It's requirements engineering, impact mapping, and so on and so on. But let's focus on the other stuff. Let's focus on the garbage that created the garbage. And let's start with the team spirit. So, how did we, when we fixed the software, not get there? And that's kind of the most important part of the talk for me is, well, if you don't change a thing, you're going to get exactly the same result. I mean, that's obvious. So we changed, or we decided we needed a significant change in team and culture. Team, sure, that's easy to define. Culture is the problematic one. So what is culture? And this guy, Henrik, he has this simple definition, if you've seen it. And he says culture is the sum of everyone's attitude and actions, so model the behavior you want to see. What's the kind of behavior you can look at? Well, we can observe behavior, and if we think this behavior is beneficial, we can encourage it. If it's not beneficial, we can dampen it. And the idea is, if you do this correctly, the culture will follow. Right? You change the behavior, the meetings that happen, for example, and then the culture will follow. So simple. Who does the management promote? Right? Is it the guy who's very good at writing lots of code? Is there fear of failure? That was much harder to recognize, but you can notice it when people are like, oh, it's Monday, I don't want to deploy. Is quality appreciated, or story points, or something else? It's all externally visible stuff. What is the delivery process? Do you log into production and then copy files over or not? And, well, is there some kind of learning exchange? Oh yeah, okay. Okay, so now let's go back from this more or less abstract thing and see if we can break it down to a person. This book, Atomic Habits, I like it personally a lot, and then kind of applied it to this legacy context, even though it's more like a self-help book, but it fits. So if you want to change behavior, there's 4 laws, the book says. You have to make it obvious. So what is the behavior you actually want to have? Yeah? You sit together as a team and define principles together, because if you don't know what's supposed to happen or what the behavior, the correct behavior is, yeah, it's not obvious. You're not going to do it. You have to have a shared purpose. So our team was very good at saying, okay, we want to have this software, we want to make the software better. That was our starting point. But that was our shared purpose from the beginning. And once we had it live, we sort of deflated a bit and we had to find a new shared purpose. And then, obvious is before the behavior. Attractive is during the behavior. So if you have time pressure every day, you're not going to write those tests. You're not going to improve the code. You're not going to whatever you want to change in behavior. Or general, if you have any kind of pressure. And another thing we did was the refactoring score. So it was very simple, right? We had just what's it called, a check mark. So every time you refactored something or you fixed a bug, you just did it and you just counted it up. It's very simple, but it makes it very attractive to also be part of that list, to also be able to make your mark. And then easy. If you don't know how to write good code, that's going to be hard for you. So, for example, invest in a tech coach and reduce friction. If it's hard to write a test, you're not going to write a test. By the way, these are all examples. I mean, could have gone on and on with each list. It's just to get you started. And of course, once you're done, you want to encourage the behavior for the next time. You have to make it satisfying. So pair up. 2 people. It can be pair programming, but it's more like having a retrospective 2 people pairing up after having done the new behavior. And never break the chain twice. That's from Seinfeld. If you, every day, you try to refactor something, you try to write a test, you try to understand the code more. And, once in a while it comes along that something really needs to get done and it needs to be done in a crappy way, but you need to do it now. Well, okay, that's fine. But try to not do it twice in a row. Okay. I forgot about this. All of these slides are available online at Speaker Deck. You saw it at the first slide, the link, but it's also going to be in there in the end. Okay. So we built a new Colocated Team. It was also cross-functional, meaning we also had an embedded ops. And that was gold for our legacy code, having someone who actually understands operations part of our team. We didn't have access to a direct customer because the customer of the shelf software we had to fix was distributed in 10 different regions, 10 different countries actually. But we had the key accounter who was in contact with most of the customers. It was amazing because she knew pretty much everything. And she was very good at telling us, well, this feature is not used. Okay. Yeah, and the testers, especially in the beginning, you won't have much tests. So having good testers, exploratory testers, is very important. Good, let's see. Okay. Of course, we had the shared purpose, where we had that slide. And we had the shared principles, which we defined together. Now, what were our principles? We didn't have so many when it started out, but we could basically draw from the continuous delivery principles and then sprinkle in a couple of our own that actually helped us establish our purpose. So build quality in, that's from continuous delivery. And the idea is, instead of having instead of relying on inspection to increase quality, for example, a test department that 2 weeks later tests your code, your developers themselves, they try to build quality in. This was very important when you work on legacy code. You should definitely focus on the current tree. You have a huge forest that is broken and that you would want to fix, but if you focus on the forest, you're not going to get done ever. So focus on the current tree. Anytime you experience fear, you have to tackle it head on. Focus on reducing batch size. So the smaller you make something, the smaller the surface areas where a problem can be. So if you have 100 lines changed, or 10 lines changed, or 1,000 lines changed, it's going to take you much longer to understand where the problem is. Decouple deployment and release. So deployment in this case means it runs in a production environment, but release means it's actually receiving traffic, production traffic. So if you've ever heard of dark launching, we'll get to that later. But the idea is this: you can deploy to production and basically tell your proxy not to route there until you're sure you want to route there, which gives you canary releases and everything. And yeah, this last one is basically just automation. Okay. So the principles we have. Oh, there we are. Nope. Okay. Here we are the why we're doing something. And principles beat practices. Why? Because they provide adaptability. If you have a limited set of practices, you can only solve a limited set of problems. If you have principles, out of these principles you can extrapolate that's a hard word. Extrapolate new practices. Okay. So yeah, we had done all this team stuff. We had spent most of early summer getting on a similar wavelength, and yeah, then the customer said, "Oh, that's interesting. Can you make Phoenix cloud ready?" Oh boy. Okay, so cloud. What's the problem with cloud? Well, you need a very good process to get it live. So that's what we're going to do about now. We sort of fixed the spirit, so now let's work on process. And this is also the domain of continuous delivery because, well, what's the spine of the continuous delivery book? It's the continuous delivery pipeline. It's basically the core practice. So the idea is this. You have an idea and you want to verify it. So what you do is you try this idea, try it in your local environment, you change some code, and then once you're satisfied, you push it to the source repository, and from there it goes. So first is the commit stage. That's your build unit test and what's it called? Linting, for example, everything that goes rather fast. Then once it passes that, you push the artifact to an artifact repository. And now every step basically pulls the artifact from the repository, tries something in a new environment, and then tags it. That's basically quality marker. So the first is, it's past the acceptance stage. Directly, automatically. Acceptance tests usually involve the whole stack. So depending how you do it, you kind of want to do a really broad stack from UI, or you want to be like, what's it called, subcontaneous, and you're like right below the API. If you're doing a single page app, that's your API. So you don't have to start in the browser. Then you go to a manual test environment. We relied heavily on the manual test environment in the beginning. And the testers basically gave us feedback and said, oh, well, this is broken, this is broken. Hey, this is actually rather nice. And they tagged it in the repository. And, you can add more stages as you like. There's soak testing, load testing, performance testing, whatever you can imagine. Of course, then we pushed it into a staging environment. And then our key accounter could take a look at it. Or sometimes, well, they could have, but we weren't at the point where they did it. Our actual users could have looked at it. And then, of course, you deploy it to production. And now comes the important part. You verify. Was it a good idea? If not, feedback, you do something different. Okay. So, what was our branching strategy? Well, don't branch, don't branch, don't branch. and never branch to refactor. So if you have this amazing idea how to refactor and you do a branch and 4 weeks later your refactoring is done, you kind of want to push it back and everything has changed. Yeah, so you're never going to do refactoring if you do refactoring branches. That's at least my opinion, and I've never actually experienced, even in healthy projects, refactoring branches to work well. So the idea is to use all small incremental techniques to do basically refactoring, which you can stop at any time. And which ties very nicely into the definition of refactoring, which is like these very tiny steps in the refactoring book by Martin Fowler, which you can just do, replace method with whatever you want. And yeah, if you ever decide to do a branch, that's, well, continuous isolation. Integration is when you have all these branches and all your work integrated all the time. Okay. Good. Of course, we version tested everything. So our original, the original authors of the code, they didn't use version control. They didn't like it. We used it for code, config, deployment script, infrastructure script, and of course documentation. They did something different. They did this. Yeah, final is missing, actually. So, by the way, this is exactly how it looked like. Like, the same. And the spelling mistake has been in there for, I don't know, I guess 15 years. Anyway, so that was our summer. Let's go into autumn. So autumn, we finally decided to go, okay, let's look at the product. Now we have a process, we can continuously deliver something. We have our Phoenix server, we have a server, we have all the scripts ready, infrastructure as code and so on. So we could just burn it down and pull it up again in, I think it was 16 minutes. Some manual steps in there. Now, let's look at product. So where do we start with the product? Yeah. You have, well, in our case, 5 million lines of not so good stuff. Where do you start? Well, you're in luck. I have a shameless plug. So it happens to be that I'm actually, or used to be, the product owner for this open source tool called Colocated. It's free. It's, you can use it if you want to. And that's why I feel okay doing the shameless plug. So this is what you do. You use NPM, you download the analysis tool, and you basically, well, run it here, parse the sources, and then you create this nice project.cc.json. So, great. Now you have basically analyzed the source code, you have extracted lots of metrics from different sources, you have combined them with the git log metrics, so you know which file has the most authors, which file has changed the most, which has the highest complexity. Okay, great. How do you visualize it? Well, we use the building, the building metaphor. No, the street metaphor. There it is. And so we have one big building, the abstract service Java, for example. And you can see it's very wide, it's very high, and it's very red. So that's 3 different metrics we applied there. So we said the size, or the wideness, is the lines of code. The complexity is the height. And the number of authors is the color. So that tells us, okay, we have a class which is, I don't know, 10,000 lines long, has a huge McCabe complexity, and it has 40 authors. That's a coordination bottleneck. And it's very complicated. It's very complex. So we should look at that. And that's what Colocated gives us, because it gives us this map, and we see all the bad stuff, and we can basically focus on that, and we can be like, okay, so that gives us a point where we can start. In the end, it's just one tool out of many. There's certainly no tool to rule them all. And other tools you could use is, for example, other tools you can use. Code Cutter I recommend to use periodically, so like every 2 months or something when you start and when you want to look, okay, have we improved? But there's also tools you can use continuously. Another periodic tool is called the quality views. Yeah, there we go. Which is by Colin Breck. Quality views is just a way to visualize stuff, but it's really cool because you can put more information there that the developers have, but tools cannot extract. So you just ask the developers, okay, different questions, and you basically colorize the buildings or the components that have the biggest problems in red. You have, of course, SonarQube, big old classic in the Java world at least, but it's got support for 30 languages, I think. And you have CodeScene, which is more focused on the metric it can extract from Git, or JIT, I guess. Structure 101, which helps you with the static dependencies. So all import statements and so on. And actually tells you, okay, you have circular dependencies, which are going to kill you. Sonar Architecture, another tool which does something very similar. And of course, Architecture Unit or Arc Unit, if you actually want to verify the rules all the time. Arc Unit only works for Java. Luckily, there's also TSArc, which works for TypeScript and JavaScript. And basically, you can say, so this component and that component and that component, they shouldn't have circular dependencies. Or that component is not allowed to access that component, or that component is not allowed to access the API layer of that component, and stuff like this. And you basically write unit tests that can run anytime your pipeline runs. Great. So now you have another problem because you have too much you can focus on. And Matthias Veras has this idea, which is, I think it was 3 post-its to refactor. So if you have your component diagram, and while developing, you notice, okay, this one is kind of shitty. Write a post-it. You put it where the component diagram, or you put it in the right module in component diagram. And then once 3 people, or you 3 times, have put a post-it there, you actually refactor it. So every time it annoys you, it's an indication. But if it happens enough, you actually be like, okay, I really need to take care of this. And yeah, but now you still have lots of broken windows. And I think the idea is now to actually counting the fixed windows. So instead of saying, okay, we have about 2 million broken windows, how about we do a burn up of how much we are fixed? I think it's a nice reframing. You might agree, you might not. Anyway, so great. Now you actually have another problem because you don't have any tests. So you're kind of scared to refactor. And this is where the gold master test comes in. And the idea is to characterize behavior before refactoring. So what does it mean? Well, you know that your component, your class, or your whole system, when you give it specific parameters, you know exactly what the answer is. You don't know why that answer is correct. You don't even know if it's, from a business perspective, correct. But you can say, okay, if I give it this input, I get that output. And you can use that to refactor, because the definition of refactoring is you don't change the behavior. So great, you can refactor. So what you do is you basically capture a lot of input, and you either blast it to the UI or your API layer, or directly to your database, or just a singular class, whatever you want, and shoot it to the legacy system. You capture the output. The output you can get from also multiple sources. We get to that. And great. Now you refactor the system, the class, the component, or redesign it. Capture the output again, and you compare. And if you did your refactoring correctly, nothing should change, right? So that's an amazing technique which helps you if you have no test at all. And here's a small cheat sheet, because you have first the input. You have lots of, first you need to have lots of different input, because you need to check that you have enough coverage. If you only have 10% coverage, it's not going to help you much. You can capture it from production, which is kind of the best way, but it doesn't cover all cases, because you know that end of the year report is only generated end of the year. Or you can generate it semi-randomly if you want to. Or you can try this other tool called Test Recorder. I haven't tried it, but I saw it at a conference and it was really cool. You have to beware of hidden inputs. Okay. Anyway, it's going to come later. So hidden inputs are, for example, the date, or like anything that is time-based. Can also be other stuff. Then you have output, which you need to capture, which is, for example, log messages. If you don't have enough log messages, you can add new ones. You can get it from your data lake, or directly, verify database state. There we are. Okay. Randoms, of course. I forgot that one. And when should you do that? Well, every time you want to do a big refactoring. And, every once in a while, you will actually change the behavior. So that's when you need to regenerate your output. Good. So, great. Now, how do we refactor what we can't understand? I call this nope factoring. It's not the official term. It's not by me, but I like to give it a name. But basically, you can refactor without thinking. And it works by sort of lifting up conditionals and then splitting to classes. I'm not going to go into the detail, but there's a really good video by Emily Bach down here, where she explains this and she shows you how to do it. And the amazing part is really, you don't have to think at all. It's amazing. Trust me. But I didn't want to not include it. Anyway, so great. Okay, we have our gold master. We sort of know where to start. We have actually fixed a couple of things. And then a customer comes in and is like, hey, can you please add this feature? And of course, I'm like, yeah. So yeah, now comes the next part. We need to conquer the fear. We're afraid to change code. We have sort of implemented the first couple of things, but now we need to actually change the behavior. So the gold master tests don't really help us that much. And what you do is you write even more categorization tests for smaller parts, function tests if you actually understand what the correct answer is. You can actually deploy it safely to production, verify it works there. We get to that. And yeah. And for me personally, it helps really much to divide code into stable and unstable. Meaning unstable, oh, I better not touch that, and stable, it's covered by tests. And if you can basically separate them, that's going to help you a lot. And of course, by understanding the core domain. Well, but the core domain, 15 years old, the developers are no longer here and the users don't understand it either. So what you do, I call this reverse object mother. Naming is hard, sorry. So basically what you do is you start the application. You don't have anything in your database and you don't have any domain model. At least in our case, there was none. It was direct SQL statements. So you start it, you click through a use case, and then you discover, okay, well, it's going to break like immediately. And then you notice, okay, my app needs at least an object A with this field. And then you basically recreate the domain model. You sort of discover what the developers thought the domain model was. Recreate the domain model, and then you use the domain model to recreate the state in your database. And then you repeat, and then you click through the same use case or a different one, and you discover it breaks in a different state. And then you go and discover, okay, well, so apparently my object A needs another field. And then you do this again and again and again and again, and you basically reverse engineer the domain model. Right, and of course you document your finding as a categorization test. Great. All right. Okay, so that's kind of where you start. Yep. And now what you do is you basically you sort of try to organize this, and you put the red stuff where the red stuff is, the blue stuff where the blue stuff is. And you do this by different techniques. All of these are from, or some of them are directly in, working effectively with legacy code. Others I sort of added. So if you have direct read and write, you can put a facade pattern in between there. If you have classes which directly depend on each other, you can instead use dependency injection and have an interface in the constructor. If you have fire and forget calls, meaning calls where you don't really care if something comes back, you can use an event. And if you have like obsolete or duplicated tables, I mean, we had 4,000 tables and not all of them were used. 8 minutes, okay. If you can put like a table view in between. I know most people consider it bad to use database table views, but they're really helpful if you just want to throw this table away. Right? Because if it's just the read access, you can just put a table view in between. And if in our case you have lots of these GET requests, which just happen like, and sometimes the string for the GET request is built dynamically, you can replace that with an explicit constant. And that just makes it explicit, and you just put it in the same class, for example, that you have all like 6 GET requests, which you always fire all the time, and that helps you a lot. And of course, now you basically start to get this. You have these boxes of not so good stuff, and in between you have the interface and the facade and the event and the table view that kind of isolate them from each other, which helps you in your brain. Because now you're like, okay, so if I'm in this one, I only have to think about this one. And then you can start sprouting quality code, which is whatever your favorite method of creating quality code is, but the default one is TDD. And you can just put it in there and like have this new class, and this class is called by the old code, or the new class calls the old code, or whatever is relevant in your case. Of course, you can only use that or you can use it for smaller things, but sometimes you realize, okay, this is actually a big feature, and I kind of don't want to put this big feature in the old stuff, because then I'm always going to have old stuff. And that's where the Strangle application comes in. If you've been in the reverse proxy presentation after lunch, you know this pattern, because you have the web browser and you have a proxy, and the proxy links links every request to the old code. But because you have a proxy, you can decide, okay, well, the new, I don't know, feature, what was the feature called? Pizza. /pizza now goes to the blue box. And realize, okay, well, we really want to put a bakery in there, or really want to increase our pizza production. So now we sort of build this up and increase the blue code, and can incrementally decrease the red code, because less and less stuff, and we move more and more stuff to the new code. The new code is nice and you understand it. And this is a long process. I think Amazon started like this, 2000 and something, and it took them 7 years to break down their monolith. So it's not overnight, but the big benefit is you don't have to shut down ever. Right? You do this incrementally and you reduce the risk and everything. Okay, so anyway, winter. We've spent a lot of time fixing stuff and some time implementing new features. And one of the most successful things we tried was dark launching, meaning very similar to a Strangle application. We have this load balancer in between, which usually goes to the legacy code, but we sort of split the traffic, and exactly the same requests also go to the new redesigned system. I mean, it's, V1 legacy and V2 or V3 or whatever you want. you put it to the legacy system, and then you capture the output, again, from the old system and the new system. And you compare it all the time. And if you do daily deployments, and you check, is the number of 200 or 400 or whatever you measure, is it about the same, or is it significantly different? And you can use that even for legacy code to really gain confidence, because that is much better than every test you can write. This is production traffic. And if it handles about the same, you're gonna sleep so much better. Of course, in the end, you shouldn't ever fix something that doesn't need fixing. So whatever you do, please remove any obsolete code in test and in tech and business. So obsolete code from a tech perspective, very simple. If you work in C#, Visual Studio will tell you that code is not reachable. From a business perspective, it's much harder, because business doesn't really know what features are used. So how do you find obsolete code? Well, you can add new analytics. For example, we weren't allowed to use that for legal reasons. We weren't allowed to add Google Analytics directly to the page, but there are self-hosting solutions which you can use. Yeah. You can also dark launch your pages again, and you can check there what's actually reached. Is this component even ever called? You can do user service. What do you use? Do you know about this feature? Which is what our key counter did. IDE suggestions, this path of the code is never reached. What we also did was we created a grep script, and it checked our source code for every from, insert, join, update, delete, and we could sort of plot, okay, in this part of the code, that database area is reached. In that part of the code, that database area is reached. Legacy toggles, which are basically, if you think this code is never reached, you do an if-else or an if around it. And if it is reached, you either throw an exception if you want to, or you give a canned response back, some default response. And if no one complains, you're happy. And we forgot to deploy parts of our application. Also works. Saved the company $40,000 per month because the service was not used ever. Anyway, so was it successful? Before, 2 weeks for a feature, 5 months until it worked, because they had to rework all the time. They realized, okay, well, we added this feature, and over there something broke, and then you went there, and over there something broke. In our case, now after 4 weeks, it just works. Was it worth it? Users before had capitulated. They didn't even file bugs anymore because they knew no one would actually answer it. It was much more stable than before. To this day, no one knows what same as before means. So if someone tells you, hey, reread this, you don't know what the features are. Yeah, and we had the seamless migration. There was pretty much no feature freeze ever. Would I personally do it again? Yes. Because why? We had autonomy, mastery, and purpose. We were allowed to do what we wanted. We were allowed to improve at what we did, and we knew why we did it. And down there, that's from Drive by Daniel Pink. Right, that's the summary. Always conquer the fear. Use really cool patterns like Strangler and Golden Master. And please don't ever forget the continuous delivery pipeline. And please remember, it's not continuous delivery if you can't deploy it to production right now. Thank you.